Let's try to understand how to create EC2 instance in AWS step by step. What is AWS? Amazon EC2 instance. An EC2 instance is nothing but a virtual server in Amazon Web Services technology. It stands for Elastic Computing Cloud. It is a web service where an AWS subscriber can request and provision a compute server in AWS cloud. On-demand EC2 instance is an offering from AWS where the subscriber user can rent the virtual server per hour and use it to deploy his/her own applications. The instance will be charged per hour with different rates based on the type of the instance chosen. AWS provides multiple instance types for the respective business needs for the user. Thus can rent an instance based on your own CPU and memory requirements and use it as long as you want. You can terminate the instance when it's no more used and save on costs. This is the most striking advantage of an on-demand instance. You can drastically save on your capex. In this tutorial, you will learn login and access to AWS services, choose AMI, choose EC2 instance types, configure instance, add storage, tag instance, configure security groups, review instance, create a EIP and connect to your instance. What is a Spotlight instance? Create a spot request, find instances types, configure the spot instance, review your spot instance. Let us see in detail how to launch an on-demand EC2 instance in AWS Cloud. Login and access to AWS services. Step 1. In this step, log in to your AWS account and go to the AWS services tab at the top left corner. Here you will see all of the AWS services categorized as per their area with compute storage, database, etc. For creating an EC2 instance, we have to choose Compute EC2 as in the next step. Open all the services and click on EC2 under Computer Services. This will launch the dashboard of EC2. Here is the EC2 dashboard. Here you will get all the information in gist about the AWS EC2 resources running. Step 2. On the top right corner of the EC2 dashboard, choose the AWS region in which you want to provision the EC2 server. Here we are selecting, and Virginia AWS provides 10 regions all over the globe. Step 3. In this step, once your desired region is selected, come back to the EC2 dashboard. Click on Launched Instance button in the selection of Create Instance as shown below. Step 4. Instance Creations wizard page will open as soon as you will click Launch Instance. Choose AMI. In this step you will be asked to choose an AMI of your choice. An AMI is an Amazon machine image. It is a template basically of an operating system platform which you can use as a base to create your instance. Once you will launch an EC2 instance from your preferred AMI, the instance will automatically be boot with the desired OS. We will see more about AMIs in the coming part of the tutorial. Here we are choosing the default Amazon Linux 64-bit AMI. Choose EC2 instances types. Step 1. In the next step, you have to choose the type of instance you require based on the business needs. We will choose T2 micro instance. We'll choose T2 micro instance type, which is a I first V CPU and first GB memory server offered by AWS. Click on configure instance details for further configurations. In the next step of the wizard, enter details like no of instances you want to launch at a time. Here we are launching on instance. Configure instance. Step 1. Know of instances. You can provision up to 20 instances at the time. Here we are launching one instance. Step 2. Under purchasing options, keep the option of request spot instance unchecked as of now. This is done when we wish to launch the spot instances instead of on demand ones. We will come back to spot instances in the latter part of the tutorial. Step 3. Next, we have to configure some basic networking details of your EC2 server. You have to decide here in which VPC virtual private cloud you want to launch your instance and under which subnets inside your VPC. It is better to determine and plan this prior to launching the instance. Your AWS architecture setup should include IP range for your subnets, etc. Pre-planned for better management. We will see how to create a new VPC in networking section of the tutorial. Subnetting should also be pre-planned, e.g. if it's a web server, you should place it in the public subnet, and if it's a DB server, you should place it in a private subnet all inside your VPC. First, network selection will give a list of VPCs available in your platform. Second, select an already existing VPC. Third, you can also create a new VPC. Here I have selected an already existing VPC where I want to launch my instance. Step 4. In this step, a VPC consists of subnets which are IP ranges that are separated for restricting access. Below. Under subnets, you can choose the subnet where you want to place your instance. I have chosen an already existing public subnet. You can also create a new subnet in this step. Once your instance is launched in a public subnet, AWS will assign a dynamic public IP to it from their pool of IPs. Step 5. In this step, you can choose if you want to AWS assign it an IP automatically or you want to it manually. Later, you can enable disable auto assign public IP feature here likewise. Here we are going to assign this instance a static IP called as EIP elastic IP later. So we keep this feature disabled as of now. Step 6. In this step, in the following step, keep the option of AIM role known as of now. We will visit the topic of IAM role in detail. IAM services. Step 7. In this step, you have to do following things. Shut down behavior. When you accidentally shut down your instances, you surely don't want it to be deleted but stopped. Here we are defining by shut down behavior as a stop. Step 8. In this step, in case you have accidentally terminated your instances, AWS has a layer of security mechanism. It will not delete your instance if you have to enable accidental termination protection. Here we are clicking the option for further protecting your instance from accidental termination. Step 9. In this step, under monitoring, you can enable detailed monitoring if your instance is a business critical instance. Here we have keep the option unchecked. AWS will always provide basic monitoring on your instance free of cost. We will visit the topic of monitoring in AWS CloudWatch part of tutorial. Under tenancy, select the option if a shared tenancy. If your application is a highly secure application, then you should go for dedicated capacity. AWS provides both options. Step 10. In this step, click on Add Storage to add data volumes to your instance in the next step. Add storage. In this step, we do following things. In the add storage step, you will see that the instance has been automatically provided the general purpose SSD root volume of 8 GB point maximum volume size. We can give to a general purpose volume in 16 GB. You can change your volume size, add new volumes, change the volume type, etc. AWS provides three types of EBS volumes: magnetic general purpose SSD provides IOPS. You can choose a volume type based on your application's IOPS needs. Tag instance. In this step, you can tag your instance with a key value pair. This gives visibility to the AWS account administrator when then are the lot number of instance. The instance should be tagged based on the department environment like dev, seed, prod, endpoint, etc. This gives a clear view of the costing on the instance under one common tag. Number 1. Here we have tagged the instance as our dev underscore web server 01. Number 2. Go to configure security groups ladder. Configure security groups. Step 1. In the next step of configuring security groups, you can restrict traffic on your instance ports. This is an added firewall mechanism provided by AWS apart from your instance OS firewall. You can define open ports and IPS. Since your server is a web server, we will do following things. Number 1. Creating a new security group. Number 2. Naming your SG for easier reference. Number 3. Defining protocols which we want enabled on my instance. Number 4. Assigning IPs which are allowed to access your instance on the set protocols. Number 5. Once the firewall rules are set, review and launch. Review instances. In this step, we will review all your choices and parameters and go ahead to launch your instance. Step 2. In the next step, you will be asked to create a key pair to log in to your instance. A key pair is a set of public-private keys. AWS stores the private key in the instance and you are asked to download the private key. Make sure you download the key and keep it safe and secured. If it is lost, you cannot download it again. Number 1. Create a new key pair. Number 2. Give a name to your key. Number 3. Download and save it in your secured folder. Number 4. When you download your key, you can open and have a look at your RSA private key. Step 3. Once you are done downloading and saving your key, launch your instance. You can see the launch status meanwhile. You can also see the launch log. Click on the instance option on the left pane where you can see the status of the instance expanding for a brief while. Once your instance is up and running, you can see its status as running now. Note that the instance has received a private IP from the pool of AWS. Create an IP and connect to your instance. An IP is a static public IP provided by AWS. It stands for Elastic IP. Normally, when you create an instance, it will receive a public IP from the AWS pools automatically. If you stop reboot your instance, this public IP will change its dynamic in order for your application to have a static IP from where you can connect via public networks. You can use an EIP. Step 1. On the left panel of EC2 dashboard, you can go to Elastic IPS as shown below. Step 2. Allot a new Elastic IP address. Step 3. Allocate this IP to be used in a VPC scope. Your request will succeed if you don't have 5 or more than 5 IPs already in your account. Step 4. Now assign this IP to your instance. Number 1. Select the said IP. Number 2. Click on Actions Associate Address. Step 5. In the next page, number 1. Search for your instance and associate the IP to it. Step 6. Come back to your instance screen. You will see that your instance has received your EIP. Step 7. Now open Putty from your programs list and add your same IP in there as below. Step 8. In this step, add your private key in Putty for secure connection. Number 1. Go to auth. Number 2. Add your private key in .ppk Putty private key format. You will need to convert PIM file from AWS to ppk using putty. Once done, click on Open button. Once you connect, you will successfully see the Linux prompt. Please note that the machine you are connected from should be enabled on the instance security group for SSH like in the steps above. Once you become familiar with the above steps for launching the instance, it becomes a matter of 2 minutes to launch the same. You can now use your on-demand EC2 server for your application. What is a spot instance? A spot instance is an offering from AWS. It allows an AWS business subscriber to bid an unused AWS computer capacity. The hourly price for a spot instance is decided by AWS and it fluctuates depending on the supply and demand for spot instances. Your spot instances runs whenever your bid exceeds the current market price. The price of a spot instance varies based on the instance type and the availability zone in which the instance can be provided. When your bid price exceeds the market spot price of the instance called as the spot price, your instance stays running. When the spot price overshoots the bid price, AWS will terminate your instance automatically. Therefore, it is necessary to plan the spot instances in your application architecture carefully. Create a spot request. In order to launch a spot instance, you have to first create a spot request. Follow the steps below to create a spot request. Number 1. On the EC2 dashboard, select spot request from the left panel under instances. Number 2. Click on the button Request Spot Instances as shown below. Spot Instance Launch Wizard will open up. You can now go ahead with selecting the parameters and the instance configuration. Find instance types. The first step for spot instance is to find instance types. Step 1. Select an AMI. An AMI is a template consisting of the OS platform and software to be installed in the instance. Select your desired AMI from the existing list. We are selecting Amazon Linux AMI for this tutorial. Step 2. Capacity. Under capacity unit is your application requirement. You may decide to launch an instance based on the instance type, vCPU, or custom configuration like your choice of vPCU. Memory storage requirements. Here we are selecting an instance. If you wish to customize the capacity, you can add your choice of number 1 vCPU, number 2 memory, and number 3 Instance storage as below. Step 3. Target capacity depicts from how many spot instances you wish to maintain in your request. Here we are selecting one. Number 4. Bid price. This is the maximum price we are ready to pay for the instance. We are going to set a particular price per instance hour. This is the simplest to calculate based on your business requirement. We will see ahead how we should determine the bid price so that our bid price always remains high and don't exceed the spot price so that our instance keeps running. Just below the bid price, you can see a button of pricing history. Click on that as down below. Here in PCC history, we can see a graph depicting instance pricing trends with historical data. You can select the parameters and get an idea of the pricing of your desired instance over a period of time. Number 1. Select the product. We have selected your Linux AMI. Number 2. Select an instance type. We have selected M3 point medium. Number 3. Note the average prices for your over a day here. Thus from the chart below we can see that the instance type that we are planning to provision lies in the pricing range of $0.01XX. And it seems that availability zone, US dashboard East 1A, has the lowest price. Can't point to step 4. So let's come back to our step of quoting a bid price for the sake of maintaining our instance always available and if it falls within our budget. We can quote a higher bid price. Here we have quote a slightly higher price of $0.05. You can see some trends in the wizard itself. Number 1. Note the instances type section. Number 2. Select the instance type that we are planning to provision. Number 3. Note the price that we are planning to bid. Percent of on demand shows us that our quote price is 75% of the on demand price for the same instance type. This means we are saving 25% per hour as compared to an on demand instance. You can further lower the price and save cost drastically. Step 5. Once we are done looking at the trends and quoting or bid price, click on next. Configure the spot instance. Our next step is to configure the instance. In this step of the wizard, we'll configure instance parameters like VPC subnets, etc. Let's take a look. Step 1. Allocation strategy. It determines how your spot request is fulfilled from the AWS spot pools. There are two types of strategies. Diversified. Here spot instances are balanced across all the spot pools. Lowest price. Here spot instances are launched from the pool which has lowest price offers. For this tutorial, we'll select lowest price as your allocation strategy. Step 2. Select the VPC. We'll select from the list of available VPCs that we have created earlier. We can also create a new VPC in this step. Step 3. Next, we'll select the security group for the instance. We can select an already existing SG or create a new one. Step 4. Availability zone. We'll select the AZ where we want to place your instance based on your application architecture. We are selecting AZ underscore US underscore East underscore 1A. Step 5. Subnets. We are going to select the subnet from your list of already available list. Step 6. Public IP will choose to assign the instance a public IP as soon as it launched. In this step, you can choose if you want AWS to assign it an IP automatically or you want to do it manually later. You can enable disable auto assign public IP feature here likewise. Step 7. Key pair. A key pair is a set of public private keys. AWS stores the private key in the instance and you are asked to download the private key. Make sure you download the key and keep it safe and secured. If it is lost, you cannot download it again. After selecting public IP, here we are selecting a key which we already have created in your last tutorial. Review your spot instance. Once we are done configuring our spot instance request in the 2 steps area in your wizard, we will take a look at the overall configuration. Number 1, we can also download a JSON file with all the configuration below is your JSON file. After reviewing, we can proceed with the launching by clicking the launched button as shown below. Once we are select launch, we can see a notification about the request getting created. The spot request creation wizard will close and the page will automatically direct back to the EC2 dashboard. You can see as shown below that the state of our request is open, which means that it is getting emulated from the AWS side. AWS EC2 will check if the required instance is available in its spot pool. After a couple of minutes, you can see that the state is changed to active and now our spot request is successfully filled. You can note the configuration parameters below. Summary. Thus, we saw in detail how to create an on-demand EC2 instance in this tutorial. Because it is an on-demand server, you can keep it running when in use and stop it when unused to save on your costs. You can provision a Linux or Windows EC2 instance from any of the available AMIs in AWS Marketplace based on your choice of OS platform. If your application is in production and you have to use it for years to come, you should consider provision a reserved instance to drastically save on your capex. Here, we say how to create a spot instance request successfully by determining your bid price. Spot instances are a great way to save on costs for instances which are not application critical. A common example would be to create a fleet of spot instances for a task such as image processing or video encoding. In such cases, you can keep a cluster of instances under a load balancer. If the bid price exceeds the spot price and your instance is terminated from AWS side, you can have other instances doing the processing job for you. You can leverage auto scaling for this scenario. Avoid using spot instances for business critical applications like databases, etc. Thank you.